Hello everyone. Today I am going to give you the idea about equalization. So we start with the history of the equalization. So at first I like to tell you what is equalization and when it was first introduced. Actually, equalization is a signal processing and introduced in the year of 1964, and it was first used in wired communication like a cordless phone. But nowadays it is very popular in wireless communication to combat ISI. ISI means inter-symbol interference. We know that wireless channel is time varying, change with the time. That's why it is very important in the wireless communication. Next, what is equalization? So as I said earlier, equalization is a signal process to mitigate the inter-symbol interference. Where it is used at the receiver side to improve the quality of the signal, and it is best technique to combat the equalization, and it is the physical layer technique. And equalization enhances the signal quality and minimizes the effect of ISI without increasing the transmitted power and without increasing the signal bandwidth. And equalization can be employed in time domain, space domain, and frequency domain. Now, let's see what is the difference between OFDM and equalization. We know both OFDM and equalization are used to minimize the ISI, but what is the difference between both? The main difference between OFDM is used at the side of transmitter, but the equalization is used at the side of receiver. And both are same work, both are used to combat ISI. And orthogonal code is used to mitigate ISI in the OFDM, but in equalization we mitigate the ISI by sensing the channel. We estimate the channel and do the reverse operation to enhance the quality of the received signal. This is the main work of the equalization. So why we need the equalization? Why we need the equalization in the main point? Because in day by day we want higher data rate, but the bandwidth is limited. But in you see the figure, there are two figure 1 and figure 2. In figure 1, this is the lower data rate scenario. Here the bit 1 and bit 2 are further large. The distance between the bit 1 and bit 2 is large. Means the period between the bit 1 and bit 2 is called inter-symbol period. Okay, but in figure 2, this is the scenario of higher data rate. We can see the bit 1 and bit 2. Higher data rate means the bit are reaching the receiver side very fast. So the bit 1 and bit 2 are overlapping each other. This is called the inter-symbol interference. So we have to minimize or combat this by the process of equalization. Then we go to the types of the equalization. There are two types of equalization, linear and non-linear. And non-linear equalization is also known as a adaptive equalizer. And non-linear equalization is better than linear equalization because we all know that the noise is also there in received signal. So the noise enhancement in the non-linear equalization is less than the linear equalization. So we go for the non-linear equalization or adaptive equalization. Then let's see what is adaptive equalizer. Non-linear equalizer or adaptive equalizer suffers from less noise enhancement than the linear equalizer. As I said earlier, the design of equalizer is complex than linear equalization. We know that the linear equalizer very simple design, but the design is complex than the linear equalizer, but the adaptive equalizer is better than the linear equalizer. And adaptive equalizer must learn the frequency or impulse response of the channel or estimate the channel so that we can do the reverse operation to minimize the ISI effect. Then this is the figure of adaptive equalizer. This is baseband signal or original signal XT. Then it goes through the channel like modulator, then transmitter, then radio channel. Then we get FT. This is the front side of the receiver. Then it pass through the RF receiver front end, IF stage, and then match filter. Match filter, why is match filter? Match filter improves the signal to noise ratio, or we get the high SNR. So we do use the match filter. Then we get here the noise is added NT. So XT plus NT we get. So YT is equal to XT plus NT. It goes to the equalizer. This is the equalizer. The impulse response of the equalizer is EQT, and then D dash T. Then D dash T goes to the decision maker, and then after decision maker DT is received. So we have to check the both are same or not. Okay, both are same or not. Then the decision maker take the decision and reconstruct the actual signal by minimizing the noise. This is the diagram of the adaptive equalizer. So what is the methodology then? The methodology is of equalizer has two operating mode. So adaptive equalizer has two operating mode, training and tracking. So what is training mode? It precedes the training mode. It precedes the tracking mode. It precedes the tracking mode. Tracking mode से पहले ये training mode का काम होता है. In this mode, we are sending known PN sequence to understand how the channel is. We are sending known PN sequence to understand how the channel is, and it measures in this mode we measure the frequency response of the channel and the fixed a weight to overcome the ISI. The training sequence is designed to permit an equalizer at the receiver to acquire the proper coefficient in the worst possible channel condition. What are the worst condition? Fading, intersymbol interference. These are the path loss. These are the worst condition channel. Then training mode. The training sequence is designed to permit an equalizer at the receiver to acquire the proper coefficient in the worst possible channel condition. Therefore, the training sequence is finished. The filter coefficient are near optimal. Okay, the near optimal हो जाने के बाद वो training sequence जो है वो ख़त्म हो जाएगा. And the receiver side, a recursive algorithm is used at the receiver side to evaluate channel and estimates the filter coefficient to compensate for the channel. अगर हम लोग को पता चल गया कि चैनल कैसा है, तभी हम लोग अगर उसका रिवर्स ऑपरेशन उसको कर देंगे तो हम लोग का एक्चुअल सिग्नल मिल जाएगा ना. वी इफ़ यू नो द सिग्नल चैनल तो वी इजीली do the reverse operation and we reconstruct the original message. Then comes the tracking mode. In this mode, we sense the channel. If the channel changes very fast, then we switch to the training mode again. When the data are received, the adaptive algorithm tracks the changing channel. What tracking mode, what the equalizer does? The equalizer tracks the channel, how it changes with time. As a result, the adaptive equalizer continuously changes the filter characteristics as the wireless changes is time varying. Right? So these are the operating mode. Two modes are there, training and tracking mode. Then we go to the working of adaptive equalizer. The original signal is XT, as we know in this case diagram you see XT. It passed through the channel. So we get YT. YT is equal to XT convolution HEQT plus NT. The HEQT is the combined impulse response. It is the combined impulse response, and the NT is the noise power, aggregated noise power. Then EQT is the impulse response of the adaptive equalizer, right? The equalizer output then D dash T xt into HEQT convolution EEQT plus NT convolution EEQT. EEQT is the impulse response of the equalizer. The goal of equalizer, impulse response of the equalizer. So when we get the actual signal, when D dash T is equal to xt and the right hand side NT plus EEQT becomes 0, then we get the original signal, or we construct the original signal. This only adaptive equalizer does. So the goal of the equalizer is to satisfy the above equation. When the above equation satisfied, when GT is equal to HEQT convolution EEQT, which consider the delta operation, then D dash T is equal to XT, मतलब XT is equal to ओरिजिनल सिग्नल हम लोग को मिल जाएगा. जब D डैश T इज इक्वल टू XT हो जाएगा तो हम लोग को ओरिजिनल सिग्नल मिल जाएगा, मतलब जो हम लोग का काम है इक्वलाइज़र का तो वो सेटिस्फाई कर जाएगा. देन कंपैरिजन बिटवीन द लीनियर एंड non-linear equalization. The effect of noise is less in the adaptive equalizer than linear equalizer, as I said earlier. The noise का जो effect होता है ये linear में ज़्यादा होता है, non-linear में कम होता है. And adaptive equalizer are used in many application where channel distortion is too severe for the linear equalization to mitigate the effect of the channel impairment. जब channel condition बहुत वर्स्ट है, मतलब फेडिंग है, पाथ लॉस है, तभी हम लोग को ये एडेप्टिव इक्वलाइज़र इज़ बेस्ट.